All right, so for this question, let's take a look at what the question is saying. So Louise travels to work and home again by train. It says that the probability that her train to work is late is 0.7 and the probability that her train home is late is 0.4. So what is the probability that at least one of her trains is late? All right, so first of all, we just need to draw all the probabilities by a tree diagram, like all the possible outcomes. So this is the train to work. And then we have the train home. So we have two different possibilities for the train to work. One of them is late, the other is not late. And the same goes for the train home. So actually we can derive the branches late, not late, followed by late, not late. All right, so that's what we have. This is the tree that we have. So next, we are just looking at the probability that at least one of her trains is late. So what are the cases that one of the trains is late? First of all, we know that if the train to work is late, then both of these cases are going to be having one of the trains late at least. And even if the train to work is not late, if the train home is late, then, well, of course, at least one of her trains is late. So now we can see that for these three cases, at least one train is late. All right. So in order to find the probability that at least one train is late, actually, one alternative is to find out the probability that no train is late, which is going to be this one. And as long as I can take it away from the total probability that is going to be 1, I will see the probability that at least one of her trains is late. So what is the probability that her train to work is not late? It's going to be 1 take away 0.7, which is the late probability, and that gives me 0.3. And what about the train home? It's going to be 1 take away 0.4, which is 0.6, all right? So the probability that neither of the trains is late is going to be 0.3 multiplying 0.6, that is 0.18. All right, so now the answer, you just need to take away 0.18 from 1, and you can get the answer 0.82. And that's going to be the probability that at least one of her trains is late, okay? Now, let's look at the second problem. It says that the probability that a learner driver passes their driving test is set to be 0.4. If they fail the first test, the probability that they pass the second is 0.5. If they fail the second test, the probability they pass on the third attempt is 0.3. So what is the probability that the driver passes their test before their fourth attempt? All right, so this one is slightly harder than the previous ones, because if the driver passes, the driver doesn't have to take any more tests. So the tree can be drawn like this. So for the first attempt, it's either going to be pass or fail, right? But then after the pass, we don't need to move on to the second one. It is only when we fail, then we move on to the second one. So that's going to be pass and fail for the second test. And then for the third test, it goes the same. If I pass, I don't need to move on. So when I fail, there will be pass and fail for the third test. All right. So the question is asking you the probability that the driver passes their test before their fourth attempt, which means that unless the driver fails in 3 consecutive attempts, the driver is definitely going to pass the test. All right, so now let's write down the probabilities for passing or not passing each time. So this is going to be 0.4. So fail is going to be 1, take away 0.4, that is 0.6. And after that, we have 0.5 here. And the failing probability is going to be 1, take away 0.5, that is 0.5. And then we have pass on the third time is 0.3. So the failing probability is 1, take away 0.3, that is 0.7. All right. So now, if the probability is failing all three of them, that's the only case that the driver cannot pass the test before their fourth attempt, right? So what is the probability of failing 3 times in a row? It's going to be multiplying all of these probabilities together. So you have 0.6 multiplying 0.5 multiplying 0.7. And that's going to be 0.21. All right, because 0.6 multiplying 0.7 is 0.3. 0.3 multiplying 0. So 0.6 multiplying 0.5 is 0.3, and 0.3 multiplying 0.7 is 0.21. Okay, so the probability that the driver is going to pass will just be taking the failing probability away from the total probability, and that is going to be 0.79. All right, so that is the answer to this question.